This is Geometry 3.4b. We talk about proofs about lines and angles. This is the second day that we're working on this. Today we're going to talk about a linear pair, we're going to talk about vertical angles, and some of the equations that can be created with those. So a linear pair are supplementary, have to be two angles that add up to 180, and they have to be adjacent. So it has to be next to each other, and they have to form a straight line. That is called a linear pair. And in our proofs, sometimes we're told these two angles are a linear pair. So in our proof, we'll be able to then say how those two angles are supplementary. If two angles are a linear pair, then they are supplementary. You can't go right to 180. You got to go through supplementary first. This is a really important one. Vertical angles. Vertical angles are formed by two lines that are making a big X. If you have a big X, and those are the angles opening in opposite directions, or you have a big X, and those are the angles opening in those opposite directions, those are considered your vertical angles. So the way that we're going to write our proof, what's always true about vertical angles is that vertical angles are congruent. If vertical, then congruent. That's as basic as you can say it. If you like to use more words in your proof, if two angles are vertical angles, then they are congruent. That's just fine. That's perfect. This is as abbreviated as you can go. You have to have the if-then. You got to talk about vertical first, and you got to say that they're congruent. Vertical angles are congruent. And you know congruent means the same measure. If you look at that, those two angles, as they open, both the top and the bottom are both getting larger, and the sides are both getting smaller. And as you close them up, the top and the bottom are both getting smaller at the same rate. So that's why they're going to be the same measurement on both sides. So now we know what a linear pair looks like. They have to form a straight line. We know what vertical angles look like. They open in opposite directions of a big X. Can you identify which of these angles is a linear pair, vertical angles, or neither? So go ahead, pause the video. Angles 1 and 2, have to decide which type of angles those would be. 4 and 2, 1 and 3, and 5 and 8. Which ones are vertical? Which ones are linear pair? Which ones are neither? Pause the video, work that out. We'll come back and work it out together. All right. Here we're looking at angles 1 and 2. Angle 1 is right there. Angle 2 is right there. Together you see that they're making that straight line. It's half of a circle when you connect those two angles together. So this is a linear pair. They are adjacent and they're supplementary. 4 and 2. There's 4. There's 2. And you see that they're formed by a big X. And they're the angles opening in opposite directions. So that falls underneath vertical angles. 1 and 3. 1 and 3 are also about that big X. And they're also opposite of each other. So they're vertical angles. 5 and 8. What result did you come up with for 5 and 8? They have different vertices. 5 has a different vertice than 8. Linear pair has the same vertex because they have to be adjacent. Vertical angles also need the same vertex. So when we look at 5 and 8, they don't even have the same vertex. They're going to fall under neither. I'd guess that 5 and 7 are supplementary, but that does not make them a linear pair. They have to have the same vertex. All right, looking at the measurement of angle 4, so using this picture to the right, we have 63. That's the measure of angle 4 is 63. If that's 63 degrees, what's the measurement of the other 3 angles? So pause the video, work through that, come back, and I'll work through it with you also. Here we see that angle 4 is 63 degrees. I know that angle 2 is just like angle 4. Angle 2, comma, angle 4 are vertical angles. So I know that the measurement of angle 2 is going to equal the measurement of angle 4. So 63 is going, actually I did that backwards. I don't know what the measurement of angle 2 is, but angle 4 is 63. Angle 2 would have to be 63 also, because they are vertical angles. They're formed by a big X. Now the big question is, how do we work with 1 and 3? Well, angles 4 and 3 form this straight line. 4 and 3 are a linear pair. So I know that 1 and 4 are going to be supplementary. Angle 1, comma, angle 4 are a linear pair. That means the measurement of angle 1 plus the measurement of angle 4 is going to add up to 180 degrees. If angle 4 is 63, then I can subtract my 63 to get 117. And that's going to be 117 degrees. And I know that angle 1 and angle 3 are vertical. So the measure of angle 3 is going to be 117 degrees, because it's going to be the same as 1. Some people talked about how they all add up to 360 degrees. And you could do that. You know, this is 63. You know, that is 63. You know, it totally equals 360 all the way around. So you get 234 degrees left over after subtracting 126 from 360, and you divide that by 2. But that's not using linear pair. And we might as well use that. It keeps the number smaller. No need to get so big. Now you got to come up with some problem solving. What do you recognize? What do you know about the angles that are provided here? You got to look at their relationship. What's the relationship between the 113 and the 4x minus 1? They are forming a straight line. This angle and this angle, do they make a big X? Not exactly. They make that straight line when you put those two angles together. So I know that 4x minus 1 plus 113 add up to be 180 degrees. They're side by side. They form a straight line. I'll collect my like terms and call that 112. Subtract my 112. That's 68. Divide by the 4. 4 goes into 6 one time with 2 left over. 4 goes into 28 7 times. So I got the answer for x to be 17. And they want us to find the measurement of angle x. So I'm all set. What relationship do we see over here with letter B? They are vertical angles. Take a look at them. If you trace out the first angle and you trace out the second angle, are they creating two lines making a big X? When you trace out the first angle and trace out the second angle, that's exactly what they do. So these two angles are vertical. We know vertical angles are always going to be equal to each other. So then you can do your algebra. I bring my x's together. I can add my 18, and I get 22. It's not 22 degrees. It's just 22. When you plug it in here, then you get your degrees. 22 times 4 is 88, minus 18 sounds like 70. So that's 70 degrees. But the 22 is not a degree. Any questions? So next we flip over. Let's take a look at letter A. What do you notice with letter A? Look at the picture. I see that we have x's and I see that we have y's. We cannot work with an x and a y at the exact same time. So you have to look for the variables that are the same. Then you want to look at the relationship between those angles. What's the relationship between the two angles that are here?
It's a linear pair.
We have a linear pair, so we know that 16x plus 9x and 5 is going to add up to 180. Here we group them together, and we get 25x. We minus our 5 to get 175. Divide by 25, and we get 7. So x has to be 7. Now if you know x is 7, what can we do? How does that help us figure out the value of y? So you may choose to use these two angles. You know that 4y has to be equal to 9x plus 5 because those are vertical angles. They're formed by a giant X and they're opening in opposite directions. But I have two different variables. But one of these variables, I know what its value is. So 4y equals 9 times 7 plus 5. 4y equals 63 plus 5. 4y equals 68. And from 68, we can divide by 4, and we get 17. 4 goes into 6 one time with 2 left over. 4 goes into 28 7 times. You can do these without a calculator. It takes calculations for you to show where these come from. No magic answers. So let's look at letter B. What do you see? What's the relationships that you see when you look at all that information?
Like the things
the x's, they're not next to each other. They're across from each other, and this is a big X. So they are considered vertical, and so are y's. The y is across from each other. So really, the only thing we can do is 9x plus 2 equals 10x minus 7. The math is easy. Deciding that these are equal to each other is the whole part of the geometry that you're talking about. You can be really good at algebra, but if you don't understand why you set up the equation, then you can't calculate it. If you understand why you set it up and have troubles with the algebra, now that's a different story, and we'll have to keep working on that. So we know that x is 9. And then we can come over and notice the y's are across from each other. So 9y plus 61 is going to equal 18y plus 25. I can move my 9y over. Subtract my 25 from both sides. And divide by 9. And I've shown all my steps all the way through. That x equals 9 and y equals 4. So we have our x and y. The directions say solve for x and y. It doesn't say find the measure of the angle, so we don't have to take it any further. It often could say that, and you would have an extra step of plugging in your x, your 9 value, into the x term. All right, on more of a geometry note, we're going to talk about this theorem, and then we're going to prove the theorem. By definition, a theorem is something we're allowed to prove. A postulate is something that we accept to be true, but a theorem is something we prove. That may be on your final exam. If two angles are right angles, like in our picture, we have angle K is a right angle, angle L is a right angle. If two angles are a right angle, then they are congruent. They're going to be the same value, the same size and shape, really. So we come down here and we see that angle K, and just to save room, I'll say comma, angle L, are right angles. So angle K and angle L are right angles. Because they're right angles, what do we know? If right angles, then 90 degrees. We know that right angles make 90 degrees. The measurement of angle K is 90. What else is 90? The measurement of angle L is 90. Because they're both 90, they're both equal to each other. That's called the transitive property. If K equals 90 and 90 equals L, then K equals L. If two angles are equal, then they are congruent. So you can simplify that as just if equal, then congruent. Now you've shown that right angles are always congruent. We can use that to help shorten up our proofs in the future.